In this video, I'm going to talk about respiratory balance sheet or energy balance sheet of aerobic respiration. What do you mean by this balance sheet? Balance sheet is a calculation of net gain of ATP in the aerobic respiration, or in other words, it is simply the calculation of amount of energy gained in the form of ATP when one molecule of glucose is broken down, or when one molecule of glucose is oxidized, or when one molecule of glucose undergo aerobic respiration, what is the amount of ATP produced in that process. So that calculation is nothing but the balance sheet or respiratory balance sheet. And in the previous video you have studied that energy is not only produced in the form of ATP, it is also produced in the form of NADH and FADH2. So to calculate the net gain of ATP in the aerobic respiration, even you have to calculate the number of ATP, number of NADH and number of FADH2 produced in the first three steps, that is glycolysis, oxidative decarboxylation and in the Krebs cycle. Why not we are talking about the ETS or ATP synthesis? Because of the ETS and ATP synthesis, the NADH and FADH2 which are produced in the first three steps is utilized to produce ATP. So now we'll talk about number of ATP, NADH or FADH2 that are produced in glycolysis, oxidative decarboxylation and the Krebs cycle. In the first step, that is in the glycolysis, 4 ATPs are synthesized. Specifically in the second half of glycolysis, 4 ATPs are synthesized. 1 ATP is synthesized during the conversion of 1,3-bisphosphoglycerate to 3-phosphoglycerate, and one more ATP is synthesized in the last step, that is during the conversion of phosphoenol pyruvate to pyruvate. And you know that these steps takes place twice, because 2 molecules of 3-phosphoglyceraldehyde is converted into 2 molecules of pyruvate. So each step takes place twice. That is why 2 ATPs are synthesized during the conversion of 1,3-bisphosphoglycerate to 3-phosphoglycerate, and 2 ATPs are produced during the conversion of phosphoenol pyruvate to pyruvate. So total 4 ATPs are produced in the second half of the glycolysis. Out of these 4 ATPs, 2 ATPs are utilized in the first half of the glycolysis, that is during the conversion of glucose into glucose 6-phosphate and during the conversion of fructose 6-phosphate to fructose 1,6-phosphate. So out of 4 ATPs, 2 ATPs are utilized in the glycolysis. That is why net production of the ATP in the glycolysis is 2 ATP, or net gain of ATP is 2 ATP. Next is NADH. In the glycolysis, NADH is produced during the conversion of 3-phosphoglyceraldehyde to 1,3-bisphosphoglycerate. And you know that this reaction takes place twice. That's why 2 NADH2 is produced during the conversion of 2 molecule of 3-phosphoglyceraldehyde into 2 molecule of 1,3-bisphosphoglycerate. So total 2 NADH2 is produced, and each NADH2 can produce 3 ATP. That's why 2 molecule of NADH2 into 3, that is 6 ATPs. So total 6 plus 2, 8 ATPs are produced during the glycolysis. Next step is oxidative decarboxylation. Oxidative decarboxylation is a single step where pyruvate is converted into acetyl-CoA. So no ATP is produced in this step, and only one molecule of NADH is produced during the conversion of pyruvate to acetyl-CoA enzyme A. And this step takes place twice, or 2 molecule of pyruvate is converted into 2 molecule of acetyl-CoA enzyme A. That's why 2 NADH2 is produced in this step, and each NADH2 can produce 3 ATP. That's why 2 into 3, 6. So total 6 ATPs are produced during oxidative decarboxylation. Next step is, or third step is, Krebs cycle. In the Krebs cycle, ATP is produced during the conversion of succinyl-CoA to succinate, and 2 molecule of acetyl-CoA undergo 2 Krebs cycle. That's why total 2 ATPs are produced during the conversion of 2 molecule of succinyl-CoA to 2 molecule of succinate. So 2 ATPs are produced in the Krebs cycle. In Krebs cycle, the NADH are produced in the 3 step, that is during the conversion of isocitrate into oxalosuccinate, during the conversion of alpha-ketoglutarate into succinyl-CoA, and during the conversion of malate into oxaloacetate. So in this 3 step, the NADH is produced, and you know that 2 molecule of acetyl-CoA enzyme A undergo 2 Krebs cycle. So 3 into 2, that is 6 NADH is produced, because each step takes place twice. That is why 6 NADH is produced, and each NADH can produce 3 ATP. So 6 into 3, that is 18 ATPs are produced. Next is FADH2. The FADH2 is produced in the Krebs cycle, that is during the conversion of succinate to fumarate, and that step takes place twice. That is why 2-FADH2 is produced, because 2 molecules of succinate is converted into 2 molecules of fumarate. So 2-FADH2 is produced, and each FADH2 can produce 2 ATP. That's why 2 into 2, that is 4 ATP. So total in the Krebs cycle 2 plus 18 plus 4, that is 24 ATPs are produced. So from the glycolysis 8 ATPs, oxidative decarboxylation can produce 6 ATP, and Krebs cycle can produce 24 ATPs. So total 38 ATPs are produced during aerobic respiration, or when one glucose molecule get oxidized, 38 ATPs are produced. Out of this 38 ATPs, 2 ATPs are utilized for transporting 2 NADH2 molecule, which are produced during glycolysis from cytoplasm to mitochondria. Because glycolysis takes place in cytoplasm, and the NADH2 which are produced during the glycolysis will be present in the cytoplasm. But this NADH2 need to undergo electron transport system, which is present or which takes place in the mitochondria. That's why NADH2 need to be transported from cytoplasm to mitochondria, which needs energy. So that energy is used by these 2 ATPs. So from 38 ATPs, 2 ATPs are used for transporting 2 NADH2, which are produced during glycolysis from cytoplasm to mitochondria. So net gain of ATP during the aerobic respiration is 36 ATPs, or 36 ATPs are produced when one molecule of glucose is broken down, or when one molecule of glucose is oxidized, or when one molecule of glucose undergo aerobic respiration. The net gain of ATP is 36 ATP. Anyhow, these calculations are only theoretical. Practically, inside the cell, all these reactions or steps will take place simultaneously. They do not take place one after the other, and all the steps of these reactions are controlled by many factors inside the cell, and ATP synthesized are also utilized as and when it is required. So all these things are not under our control. But anyhow, when you assume that all these steps takes place one after the other, one can tell that one glucose molecule can produce 36 ATPs, or when one glucose molecule undergo aerobic respiration, or when it is get oxidized, it will produce 36 ATP, or net gain of ATP during the aerobic respiration is 36 ATPs. So that is all about the balance sheet or respiratory balance sheet. I hope this video will be useful. If you like this video, please hit the like button and subscribe to my channel. Thank you.